we've got 10 teams of 6 people coming in over the weekend, starting at 10 o'clock tomorrow, to have some fun and play about some electronics and some graphene ink and see if we can create any exciting new products.
I think I'm most dreading the pitch. We only have 5 minutes and it's on the final hour of the whole event. So it's really combining everything we have learned in that 24 hours into a 5-minute pitch. The panel has 4 judges and each one of these judges will have a different specialism and different experience. It's trying to pitch Dragon's Den style to try and really go for the win.
So with this event, what we're trying to achieve is to get people who usually will not be involved and not be using graphene, to give them some graphene, give them all of the facilities they need to create a product. A team of experts in their own fields, or they've not used graphene before, they perhaps don't even know the potential of graphene, what graphene can actually do, and see what they can come up with. Team dynamics is going to be a really important issue. Professionals from many different sectors, artists, textiles, engineers, physicists, biologists, chemists, all these people from different industries all coming together to work. In some cases have not met each other before. It's going to be really important to gel and get that team dynamic going.
You come here and you don't know what you're doing, you've never seen one of these weird things before, that's absolutely fine, you can learn, that's the point, and that's what we want you all to do today. There's no one here who's an expert in all the devices you see, there's no one here who's an expert at the same time, okay, so you can all contribute something to the team.
Graphene is billed as this magic material that can do and solve pretty much anything. It's got really fantastic properties for conductivity, so for electronics. It's got really great thermal properties. It's stronger than steel.
Well, over the next 24 hours, the people who will make graphene 2D materials into products into the future is the talent of who's in the room today.
It was a hardware hackathon, the first that's ever been held for graphene.
So everything that happened was new and novel.
We're working a sort of globe to help people with special needs to communicate.
The idea is to get like British Sign Language to text, and then we can use like a built-in text-to-speech library to have somebody communicate via a computer. The most challenging part is knowing when the fingers are bent. The idea is to use the changing impedance of the stretching fabric with the graphene ink to kind of detect if the finger is bent or not.
Hello, I'm Nicole, I'm in Team 2. We've finally got an idea. Cycling safety, going to use graphene ink to print on the inside of gloves. Yeah, when you indicate, put motion sensors on your side, you bright lights turn on.
Just using very simple prototyping, using copper tape and coffee cups and bits of kitchen towel.
Our idea, we're going to make a tote bag that as you walk around, it records pollution levels for where you are right now, and then we'll feed that data back.
And we've got one that's starting to work quite well. So we're just getting it screen printed down in the lab to build the first graphene prototype.
My name's Mike, I work in technology commercialisation in the nuclear sector.
I'm Phil, I work in strategy consulting, mergers and acquisitions.
We're really here on an advisory capacity to help these teams tell their story to investors in a sort of an exciting way and help them understand the kind of things that early stage investors might be looking for and the kind of messages they might want in the later stages of a venture investment.
When we say graphene ink is conductive, we mean it can carry electricity, so we can use it to build circuits. Circuits are what power any of the technology around it.
The initial idea is to make a mattress cover. The baby deforms the cover, and you know the position, where is the baby.
It's not to give too much away to anyone else. Going to weigh the contents of the bag, and depending on how heavy the contents is, a different number of LEDs is going to light up. It's a warning against back pain, shoulder pain, arthritis.
It was great from the start. As soon as they said go, the teams knew within the first 10 minutes, they organized themselves, they knew what they were going to do, and they did a lot of market research, not only into the technical nature, but they also had a commercial focus. They were doing market research, which is crucial because the gig is all about creating products that they are commercially viable.
I thought I would be flagging a lot more now than I am, and I think that's due to the energy in the room and how great everyone's been. So we got here at 9 a.m, we started hacking at 11 a.m, it's now 20 past 10 p.m, so we're coming up to 12 hours of hacking. The range of ideas, someone wants to send something up to space.
So the idea that we've developed this weekend is a self-folding solar panel for satellites, which exploits the graphene ink to trigger this motion.
They're just not satisfied with just creating any kind of product. They actually are trying to fine-tune it. I'm looking forward to the various prototypes that we will see tomorrow morning.
It is really an oily group. There's no rusty movement between us. There is a good communication.
Now is a break or make time because we will print and see if it's actually working or not.
We had a Nobel laureate visitor, and he would have seen how the material which he isolated on sticky tape in a clean room in the lab was being used by 60 different people in that room.
The teams that we were talking to has managed to get really far on in thinking about a particular type of pressure sensor that they wanted to use to help people manage their posture better. So from a commercial perspective, there's quite a lot of nice underlying market drivers of organisations push to take better care of their workers, and they've managed to go from what was a sort of nascent idea to actually already having, one, a working sensor, and two, a working piece of software that sits behind that to actually then understand that sensor data and be able to output that in a sort of interface which humans can understand. So I think that's a really nice example of how already within a few hours we've already got to sort of a back end and front end.
Oh, absolutely, and they've also seemed to have made an awful lot of progress on the commercial wrapper. I mean, they were very excited about how they might secure some IP against this concept. Absolutely pretty exciting level of maturity on all fronts.
So we're making a pressure-sensitive mat based on graphene inks to detect posture and try and correct it in lorry drivers.
Strips of graphene, a long wire trace of graphene. What we do is if you put some strain onto the graphene, we can change its resistance value just by varying the kind of properties of the material when you apply pressure or strain.
We're going to check a few different designs and move forward to a finished product.
Really, really nice to see people getting really into creating those first prototypes in a way that I actually didn't really think was possible to do so quickly, actually.
No, that's what's really impressed me too. I believe they came in here, some of them with an idea, some with nothing, and we're already seeing some sort of stuff happening on screen, some prototypes, version 1, I think a few people are on version 2 already. It's exciting to see. It's not something you see that often in the physical sciences.
With normal paper, it just goes straight through and soaks the paper, which is why it gets all crinkly like this. So this didn't really work that well. The other ones have turned out all right, a bit better. These are on cork. We don't know if this will actually conduct. Cardboard might be our best bet.
This is the next Mark II design. So we're hoping to be able to show we can miniaturise the whole thing. That's what we're quite excited about, trying to see if we can scale it down. It's going pretty good.
It's going quite well. We've got some results.
The million things that can go wrong with hardware. We had one team who managed to break 3 Raspberry Pis, and luckily we just had enough in the back to keep giving them, and eventually they got things working. Whatever problem teams had, we'd find a way together as a team and as a group to kind of get them through it. That's inherent to the hacking spirit. Things need to go wrong, sidestep them.
We're just a bit shattered now.
I feel great. Okay, indicators check, distance sensors for flashing lights check. I want to say 70% of the way there. Levers for the week.
It's 6 o'clock in the morning.
Look at the fourth one along from the A noughts. Yeah. Right, let me spin it round. Oh, can I get in there? Yeah, cool. So if I just give it a squeeze, ready? Give it a little press in there. Oh! Yes, zeros.
crunch time. Working on presentation, it looks a disaster at the moment, but we finally got our tech working again because classic, it was working all night and then in the morning it has to break.
Our first prize is the Innovation Prize. So this is for the ideas and use of graphene, the most innovative concept. Simon Howell, the head of innovation here at Geek, is going to hand that one out. So, can we please reveal our winner? The winner of the £250 prize is Graphene!
The idea is that we have, it's just the basic working model. We have 2 gestures for like hello, thank you, and then we can sign both A and B.
It's like waving Gordon.
What was the inspiration for this project?
Well, this would be really nice to help people. You have a software like this that you do this and that says hello. That would be a massive breakthrough.
Irina from the Graphene CDT is here to present the second place prize, which goes to Innovation in Pines!
So Lucas will now demonstrate by sitting down on this seat. So this seat will be retrofitted into lorries. So Lucas is now going to lean on one side.
I'm already leaning.
Yeah, leaning. You can see nice clink splodge, which is everything we want. And then he's going to now lean to the other side. And now we're going to see a real-time change in the intensity map. Oh, there's a bit of lag. There we go.
Next up is going to be our first place, the highest scoring team. We have Tony Walker, who is the Deputy Director at Masood Enterprise Centre. So, the Geek Commercialization Prize. Simon is back to announce this one as well. Representing Geek. Liquid Entity!
If you're a farmer, you might take soil samples from different fields that you own, different parts of different fields. You measure a series of different resistance values over time. You feed that data then into our sort of machine learning software.
The difference in electrical conductivity comes from the difference in organic content from the soil. So it gives an information to the farmer about the kind of specific treatment that different patches of land need to be given.
This event could not have happened without the man, the mystery, that is Vicente! The people involved in getting this to all come together has been incredible. So firstly, let's thank all of our amazing organising team in general. And it's clear how much kind of hard work and love has gone into these projects. So well done right off the bat to all of you.